All right, today is a big day. Today is the day that we grow up, we graduate from regular equations into functions. Basically, functions are just a fancy way to write the same types of things we've always been writing. So, for example, let's say we had the line y equals 3x plus 2. Now, instead of writing y equals 3x plus 2, we're going to be writing f of x equals 3x plus 2. Replacing f of x for y is how we write in function notation. Function notation. Now, it's not all that difficult to change things to function notation. Remember, we're just replacing the y with f of x. So if we had y equals absolute value of x, our function notation would be f of x equals absolute value of x. If we had y equals 3x squared, our function notation would be f of x equals 3x squared. Now when we're graphing these, if we're making a chart, or for whatever reasons, f of x is equivalent to y. We're just writing it in terms of a function rather than xy. Okay, let's get into some functions that we've dealt with but haven't necessarily graphed. So here we want to graph this function and state the domain and range. So we have f of x equals absolute value of x. Keep in mind, remember, this f of x here is really just y equals absolute value of x. These are interchangeable, the same thing. But for now, let's go ahead and get used to looking at the f of x. So the best way to graph absolute values is using a chart. Remember, we can always use a chart to graph. So I'm going to make an xy chart here. And I'm going to be plugging in values and seeing what we get for our y. So let's say I plug in negative 2. If I plug in negative 2 for absolute value, I'm going to get positive 2. So I know my y value is positive 2. Okay, let's go ahead and plug in 0. If I plugged in absolute value of 0, that would give me 0. And I'm going to get a 0 here. Okay, let's plug in, let's say, how about positive 2? If we plugged in absolute value of positive 2, we would get positive 2. So now we've got ourselves a nice little chart there of points. And we can use that chart to map our points out and connect it to get our overall graph. So let's give ourselves a coordinate plane here, and we've got the points negative 2, 2. That would be here. Let's say negative 2, 2. Let's give ourselves a point there. We've got the point 0, 0. That's going to be right here at the origin. And we've also got the point positive 2 up 2, which is right here. And if we connected these, we're going to get this V-looking graph. And absolute values are actually always going to give you this type of V. Now, it might not always be in the center, but you're always going to get this V shape here. So, recap, best way to graph these absolute values, give yourself a table of charts, draw your points, and be looking for that V. Okay, so we've got our graph, and now next they're wanting us to state the domain and range. So I'm going to leave my graph here, and I'm going to come down and let's give ourselves a domain. The domain here, remember, domain means all of the possible x values. So if I trail along my x-axis here, I have points. The graph has a point at every single x value. No matter what x value I pick, I can always go up and cross the graph. So my domain here is going to be negative infinity to positive infinity. And this is how we write that. Negative infinity to positive infinity. That means any x value we choose, that can be included in the graph. Alright, let's go ahead and do our range. Now remember, range is the y values. So now if I go along my y-axis here, if I go down here, I don't have any part of the graph. So that means these y values down here are not included in the range. Actually, my first y value comes at this 0 here. And then everything above that. See this 1, here's a point, 2, here's a point. So 0 all the way up, I have y values. And we're going to write that here we're including 0, so I give myself a bracket. That means we include it. This bracket means we include that value. We're starting at 0, and we're going to go all the way up, 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 and we can keep going and going because we know these arrows are going up and up here. So for the rest of the y values, we'll go all the way to infinity. So here's our domain and our range. Okay, let's try this one. We've got f of x equals absolute value of x minus 2. Okay, whenever we don't have an exact absolute value of x, we actually have to be really careful in which points we choose. And let me show you why. If we make our xy chart here, let's make our xy, and let's choose the same points we did last time. Let's do -2, 0, and +2. If we plugged in -2, we'd get -2 minus 2, which would give us +4. If we plugged in 0, we'd get 0 minus 2, which would give us +2. And if we plug in 2, we'd get absolute value of 2 minus 2, which would give us 0 here. And I just solved those really quickly, so those were just simplifying these absolute values here. That's all I did to get my y values here. But now let's go ahead and give ourselves a a graph here, and let's see what we end up with in graphing our points. So we give ourselves a coordinate plane. Now we've got -2, 1, 2, 3, 4. So we'll have a point right here at -2, 4. We'll also have a point at 0, 1, 2. And then we also have a point at 1, 2, 0. Now if I drew my line here, if I connected these dots, this looks like a straight line. But we know that absolute values are supposed to give us some type of v. But here we have a straight line. So what happened was, when we chose our points, we didn't choose a point that was going to tell us where to start going up in the other direction. And that's a mistake that we can often make when graphing these absolute values. So let's go ahead and let's get rid of that. Let's get and bring back our guy over here, and let's see if we can't pick maybe some more points here that are going to help us. Let's go ahead and let's pick one more. Let's pick 4. If we got absolute value of 4 minus 2, that would give us +2. So we get 4, 2. Let's go back and take a look at our graph here. Now if we plugged in 4, 2, we'd get a point up here. Now that point there it would actually tell us, oh, now we're going in this other direction, which would be up here and not following through down here. And that's what we actually want. So I'm going to give you a quick trick here in helping you pick the right points so you make sure you're graphing accurately. Let's revisit f of x equals x minus 2. So the trick is, whenever you see an absolute value, take exactly what's inside the absolute value, nothing else, and you set that equal to 0. So here we would get x minus 2 equals 0. If we solve for that, we'll get x equals 2. And this is going to be your middle point on your chart. So here let's give ourselves an xy chart, and 2 is going to be my middle point, and then let's pick a point on either side. So I know a point less than 2 would be 0, and a point bigger than 2 might be 4. So if I solve plugging in my x values for my y, I'm going to get a +2 here, I'm going to get 0, and then I'm going to get another 2 here. So when I go to graph this, let me give myself my coordinate plane. I have the point 1, 2, 3, 4, 1, 2. I have the point 0, 2 here. I have the point 2, 0 right here, and the point 4, 2 right here. and I have my nice little v. And see how this middle point that we solve for gives us the exact spot where we're going to find the v. Okay, let's just go ahead and finish this off real quick with our domain and range. We want to keep practicing that. For the domain here, we have another on the x values. We're looking at the x values. Well, for every x value, we are getting a point on the graph. So again, our domain here is going to be negative infinity to positive infinity. And our range, we're looking at the y values. So again, if I come down here, I don't see any y values on the graph for here, and just ignore this ignore this arrow down here. That's not part of our graph. I don't see any y values for our graph down here until I get to 0, and that's where I have our first y value at y equals 0. So I go ahead and give myself my bracket and I put 0, and then at every point above that, at 1 I have values, at 2 I have values, and I can keep going, and I'll keep getting values for all my positive y. So I'm going to say that we can go all the way to infinity, and there's our answer. Let's do one last example here. Let's say we had f of x equals 2 absolute value of x minus 1. I see the absolute value. I know that I need a chart, so I'll give myself an xy chart right away. But because I have some extra stuff going on here, I need to find out where my middle point is. So I'm going to take exactly what's inside the absolute value only. Now this 2 here is not inside the absolute value, so we ignore that. We just look at what's inside here, and that's x minus 1. So I'll say x minus 1 equals 0, and I'll get x equals 1. So this is going to be my middle point here. So I'm going to put 1 here. Let's pick something smaller. How about 0? And let's pick something bigger. How about 2? So now if I plug these in and get my other points, I'm going to get, well, for 0, I'll get f of 0 equals 2, 0 minus 1, which would give me 2 times positive 1, which would be 2. So I get 0, 2 here. And if I keep working with that, let me give myself, I'm going to slide this over to give myself some more room. Let's say I plugged in f of 1. This is plugging 1 in for x. That gives me 2 times 1 minus 1, which would give me 2 times 0, which would be 0. So I get a 0 there. And let's go ahead and plug in our last number, f of 2. That would give me 2 times 2 minus 1, which would give us 2 times 1, which would be 2. So I get my last point here at 2. And now I'm getting rather crowded here. Let's go ahead and take, let's throw this away, and I'm going to re-put those points in here. We had 0, 2, and let's go ahead and graph this. So give myself a coordinate plane. I've got a value at 0, 2. I've got a value at 1, 0. And I've got a value at 2, 2 right here. So I see my v, and I'm good to go. Now let's go ahead and real quickly do our domain and range. I'm going to just make this a little smaller and give ourselves some room to write our domain and range. Domain here would be, our domain is going to be our x values here. Again, we have all our x values accounted for. So we have negative infinity to positive infinity, and our range we have, again, kind of like the ones we've been doing. We have our 0 is our first y value, and then all the way up to positive infinity from there. Okay, really quickly I want to show you some different types of domain and range examples, because all of ours were kind of the same. Let's look at this graph up here. The domain for this one, again, all our x values were accounted for, so this would also be negative infinity to positive infinity, and you're going to find that a lot of times our absolute values end up like that. But our range here is actually going to be different. We don't have a y value at 0 this time. Our first y value is at 1. So for our range, we'd start with our bracket, we'd start at 1, and then we're going all the way up, and all these have values, so we'd go to positive infinity. Let's do this one over here, and this is actually the graph for, well, this is f of x equals absolute value of x minus 1. I've already got it graphed here for us, but our domain here, again, we have values for all the x coordinates, so our domain is going to be negative infinity to positive infinity, and our range here is a little different. This time we don't have a value at 0, we don't have a value for any of the positive y numbers. Our first value actually is here at negative 1, and we're going all the way down here to negative infinity this time. So how we write our range, since our smallest value we have is way down the graph down here, is negative infinity, so we start at negative infinity, and we're going until we get to 1, and 1 is our last value that we have for our y coordinate. So this range is going to go from negative infinity to negative 1. Sorry, that's a negative 1 here is our first y value. So here's just a couple quick examples of some graphs that have a little different range than the examples that we did before.